3.5 billion miles from the sun, in a region of space so dim that sunlight arrives 1,000 times weaker than it does on Earth, a planet has been keeping a secret for 35 years. It is a world of screaming winds and burning cold. A deep blue orb that NASA's Voyager 2 glimpsed for only a few hours in 1989 before racing on into the dark and never looking back. Since that flyby, Neptune has sat almost forgotten at the edge of human knowledge, too far for most telescopes to resolve into anything more than a fuzzy dot. But in the summer of 2022, something changed. A telescope built to stare at galaxies born near the dawn of time turned its mirrors inward toward our own solar system and pointed them at the eighth planet. What it sent back did not just refine old pictures, it rewrote them. And buried inside that data was a discovery so unexpected that the scientists who found it later admitted they were genuinely shocked by what their own instruments were telling them. This is the story of how the James Webb Space Telescope looked at Neptune and found a planet behaving nothing like the one Voyager 2 left behind. For most of human history, Neptune was not even a planet we could see clearly, let alone study in depth. It sits so far from the sun that sunlight takes over 4 hours to reach it, arriving so weak that at Neptune's distance, high noon would look to human eyes like a deep, perpetual twilight. Winds tear across its atmosphere at speeds exceeding 1,500 miles per hour, among the fastest recorded anywhere in the solar system. Fast enough to circle the entire planet in roughly 16 hours. Beneath that howling atmosphere lies a planet made not of rock, but of dense, exotic fluids. Water, ammonia, and methane, compressed under such extreme pressure that some scientists suspect it rains diamonds deep in Neptune's interior. This is the world Webb was about to examine in a level of detail nobody had achieved in over 3 decades. To understand why this moment mattered, you have to understand how little we actually knew about Neptune before Webb arrived. It is the most distant official planet in our solar system, discovered in 1846, not by accidentally spotting it in the sky, but through mathematics. Through astronomers noticing that Uranus's orbit was being tugged by the gravity of something unseen and calculating exactly where that something had to be. Neptune was found on paper before it was found in a telescope. That origin story alone tells you what kind of planet this is, one that reveals itself only through careful, patient inference, never through easy observation. For most of the 20th century, it stayed that way. Ground-based telescopes could barely make out a blurry blue disk. Even the Hubble Space Telescope, for all its power, could only hint at storms and cloud bands without ever resolving the fine structure of the planet's rings or its faint, ghostly moons. Then came Webb. Positioned nearly 1 million miles from Earth, shielded from the sun's glare by a tennis court-sized sunshield, Webb was designed primarily to look backward in time, to catch the faint infrared glow of galaxies that formed billions of years ago. Pointing an instrument like that at a relatively nearby planet might sound almost like overkill, using a deep space telescope to look at your own neighborhood. But that is exactly what made the Neptune images so extraordinary. Webb's near-infrared camera does not see the world the way our eyes do. It sees heat, faint reflected light in wavelengths invisible to us, and it does so with a level of stability and precision that no previous instrument aimed at Neptune had ever possessed. To appreciate what Webb was up against, it helps to remember just how limited Voyager 2's original encounter really was. The spacecraft did not orbit Neptune, did not linger, did not get a second chance. It flew past the planet at tremendous speed in August 1989, gathering everything it could in a matter of hours before continuing outward, toward the edge of the solar system, and eventually into interstellar space, where it still travels today. Whatever Voyager 2 saw in that brief window became, for the next 3.5 decades, essentially all of humanity's direct knowledge of Neptune up close. Every textbook description, every documentary image, every assumption about the planet's rings, its moons, its storms, traced back to those few precious hours. Webb was not just adding new data to an old picture. It was the first real chance in a generation to check whether that decades-old snapshot still matched reality. The first image came back in the summer of 2022, and when scientists opened the data, they were not prepared for what they saw. Neptune's rings, discovered by Voyager 2 in 1989 but seen only faintly since, suddenly snapped into focus. Bright, narrow rings circled the planet with a crispness nobody alive had witnessed in more than 3 decades. Fainter dust bands, ones so subtle they had barely registered even in Voyager's original data, appeared clearly for the first time in infrared light. One of the researchers involved in the project later described the ring system as mind-boggling, saying she had not seen this level of detail since the original Voyager encounter, and that it simply popped right out of the image. For scientists who had spent their careers working with grainy, uncertain data about Neptune's rings, this was the equivalent of finally putting on the right glasses after decades of squinting. But the rings were only the beginning of the surprise. Because Webb sees in infrared rather than visible light, Neptune itself looked almost nothing like the vivid blue marble most people picture when they think of the planet. Methane gas in Neptune's atmosphere absorbs red and infrared light so efficiently that the planet appears strange and dark in Webb's images, except in the places where high-altitude clouds catch the light and reflect it back before the methane can swallow it. The result is an image where Neptune looks almost ghostly, its familiar blue color gone, replaced by a dark disk scattered with bright streaks and glowing patches marking storm systems and methane ice clouds high in its atmosphere. It is a version of Neptune that had simply never been seen before, a planet stripped of its most iconic feature and revealed instead as a canvas of heat signatures and atmospheric chemistry. Those bright storm systems are not new to Neptune, but Webb's ability to track them is. Voyager 2 photographed a colossal dark storm during its 1989 flyby, an anticyclone nicknamed the Great Dark Spot, large enough to swallow the entire Earth inside its boundary. When the Hubble Space Telescope looked for that same storm just 5 years later, it was simply gone, vanished, replaced eventually by entirely new dark spots appearing and disappearing in different parts of the planet over the following decades. Neptune's storms, it turns out, do not behave like Jupiter's Great Red Spot, which has persisted for centuries. They form, rage, and collapse on timescales of just a few years, driven by processes scientists still cannot fully explain. Webb's infrared eyes give researchers a new tool to catch these storms as they emerge and fade, watching in a wavelength range that reveals cloud heights and structure invisible to previous telescopes. It means that somewhere on Neptune right now, storm systems larger than entire continents may be spinning up or tearing themselves apart. And for the first time, humanity has an instrument sensitive enough to actually watch it happen. And then there were the moons. Neptune has 14 known moons, tiny distant worlds that are almost impossible to photograph from Earth. In Webb's images, 7 of them appeared clearly, faint points of light scattered around the planet like witnesses to something enormous. Among them was Triton, Neptune's largest moon, a bizarre object that orbits backward relative to the planet's rotation, a detail that has convinced most scientists it was not born alongside Neptune at all, but was instead a captured object, quite possibly a dwarf planet dragged in from the icy Kuiper belt at the edge of the solar system. In Webb's image, Triton appeared as a glowing point far brighter than the icy moon itself would suggest, an artifact of Neptune's own light scattering off its surface, but a striking reminder that Neptune did not simply arrive in its current form. It captured a stranger from the outer dark, and has held on to it for billions of years. Triton itself deserves a moment of attention, because what little we know about it only deepens the mystery. During Voyager 2's flyby, scientists spotted active geysers erupting from Triton's frozen surface, plumes of nitrogen gas shooting miles into its thin atmosphere, making it one of the only handful of moons in the entire solar system confirmed to be geologically active. A captured world, orbiting backward, venting material into space, locked in a slow gravitational dance that some models suggest will eventually tear it apart or pull it into Neptune entirely, though not for hundreds of millions of years. Every new image Webb captures of the Neptune system inevitably includes this strange, doomed moon drifting nearby. A reminder that Neptune's gravity has been quietly rearranging the outer solar system for eons. At this point, in 2022, the story could easily have ended there. A stunning image, a rare treat for astronomers, evidence that Webb's precision could extend far beyond distant galaxies and into our own solar neighborhood. That alone was newsworthy. But the scientists working with Webb were not finished with Neptune. They had bigger questions that had gone unanswered since Voyager 2's brief flyby in 1989. And chief among them was this. Does Neptune have auroras? The same shimmering curtains of light that dance across the poles of Earth, Jupiter, Saturn, and Uranus? Voyager 2 had caught only the faintest hints of the phenomenon during its rushed pass through the Neptune system, tantalizing but never confirmed. For more than 3 decades, ground-based observatories using some of the most powerful infrared instruments on the planet, including facilities in Hawaii, had tried and failed to detect Neptune's auroras. It became one of the enduring mysteries of outer solar system science. Every other giant planet had confirmed auroras except Neptune. In June 2023, a team of researchers pointed Webb's near-infrared spectrograph at Neptune, not just to take a picture this time, but to break the planet's light apart into its component wavelengths and search for a very specific chemical signature. They were hunting for a molecule called the trihydrogen cation, written as H3+, a charged particle that forms in the upper atmospheres of gas giants when energetic particles slam into hydrogen-rich air. On Jupiter, Saturn, and Uranus, this molecule had long served as an unmistakable fingerprint of auroral activity. If Neptune had auroras, this is where the evidence would show up. When the data came back, the researchers finally saw what generations of scientists before them had been chasing. A strong, unmistakable emission line from the trihydrogen cation appeared in Neptune's spectrum. For the first time in the history of planetary science, humanity had direct evidence of auroras glowing in Neptune's atmosphere. In Webb's processed images, the auroras appeared as ghostly cyan splotches layered over an enhanced Hubble photograph of the planet. A haunting, beautiful confirmation of something astronomers had suspected but never been able to prove since Voyager's brief encounter decades earlier. One of the lead researchers on the project later admitted that seeing the clarity and detail of that signature after so many failed attempts left him genuinely stunned, saying it was the level of detail, not just the discovery itself, that shocked him most. But here is where the story stops being simply exciting and becomes genuinely strange. On Earth, auroras form near the magnetic poles close to the top and bottom of the planet, because that is where our magnetic field lines converge and funnel charged particles down into the atmosphere. The same is roughly true for Jupiter and Saturn. Scientists expected Neptune's auroras to behave the same way, glowing near its rotational poles. They did not. Instead, Webb detected the auroral activity concentrated at Neptune's mid-latitudes, the rough equivalent of where South America sits on Earth's globe, nowhere near the poles at all. The reason traces back to something Voyager 2 discovered in 1989, but which nobody had been able to properly study since. Neptune's magnetic field is not aligned with its rotation axis the way Earth's roughly is. It is tilted by an extraordinary 47 degrees, and it is also offset from the planet's actual center, not running neatly through its core the way a bar magnet would. This lopsided, tilted magnetic field means that the points where charged particles funnel down into Neptune's atmosphere are nowhere near the poles most people would expect. Instead of clean polar rings of light, Neptune's auroras erupt in strange, displaced patches, a planetary compass gone haywire, generating light shows in all the wrong places by any earthly standard. It is a magnetic field that behaves almost as if the planet does not fully know which way it is supposed to be pointing. Compare that to Uranus, Neptune's near twin in size and composition, which Webb has also studied in recent years. Uranus, too, has an unusually tilted magnetic field, though not tilted in quite the same dramatic way. Between the two ice giants, scientists are now piecing together the possibility that lopsided offset magnetic fields might simply be a defining feature of this entire class of planet, a consequence of whatever violent processes shaped ice giants during the early, chaotic days of the solar system's formation, perhaps enormous impacts that knocked their interiors out of alignment before they ever finished cooling into the worlds we see today. If that theory holds, it means the strange mid-latitude auroras Webb detected on Neptune are not some one-off anomaly. They may be a signature written into the very architecture of ice giants everywhere, including the countless Neptune-sized worlds astronomers are now finding around other stars. If that discovery alone were the end of the story, it would already qualify as one of the more unusual solar system findings in recent years. But Webb's spectrograph handed scientists a second piece of data buried inside the same set of observations, and the second finding is the one that genuinely rattled the research team. While measuring the auroral emissions, the instrument also allowed scientists to calculate the temperature of the uppermost layer of Neptune's atmosphere, something that had not been possible to measure directly since Voyager 2's flyby in 1989. When the numbers came back, they did not match expectations, even slightly. Neptune's upper atmosphere had cooled by several hundred degrees since Voyager's measurements more than 3 decades earlier. The temperature recorded in 2023 was just over half of what it had been in 1989. Half. For a planet that size, an ice giant whose atmosphere is governed by forces scientists are still working to fully model, a temperature drop of that magnitude in just a few decades is not a minor footnote. It is a signal that something about Neptune's upper atmosphere is far more dynamic, far more changeable than anyone had assumed. Ice giants like Neptune were long treated as relatively static, slow-moving worlds compared to the turbulent storms of Jupiter and Saturn. This discovery suggested the opposite, an atmosphere capable of dramatic, decade-scale shifts in temperature, shifts that scientists still do not fully understand the cause of. And in a strange twist, this cooling appears to explain the very mystery that sent Webb hunting for auroras in the first place. A significantly colder upper atmosphere produces much fainter auroral emissions. In other words, Neptune's auroras were not simply hidden by bad luck or insufficient technology. The planet itself may have been growing quieter, dimmer, colder for years, making its light shows fainter and fainter until only an instrument as sensitive as Webb could catch them at all. Put those two findings side by side and a strange picture of Neptune begins to emerge, one very different from the calm, distant blue world most people imagine. This is a planet with a magnetic field so askew that its auroras erupt nowhere near its poles. It is a planet whose upper atmosphere has been cooling dramatically for over 30 years, for reasons scientists have not fully pinned down. It is a planet holding a captured world in permanent orbit, a stolen moon from the outer solar system that drifts backward against Neptune's own spin. And it is a planet whose rings, invisible to nearly every instrument built before Webb, turn out to be intricate, structured, and strangely well preserved, despite orbiting through one of the coldest, darkest regions of the solar system. Scientists have been careful to note that these findings are only the beginning. Further observations of both Neptune and Triton were already planned in the months following the initial ring images, and the aurora and temperature data have opened entirely new lines of research into how ice giant atmospheres behave over time. There's a broader reason this matters beyond Neptune itself. Astronomers have discovered that ice giants, planets like Neptune and Uranus, may actually be the most common type of planet in the galaxy, more common than gas giants like Jupiter, more common than rocky worlds like Earth. Every new detail Webb uncovers about Neptune's atmosphere, its magnetic field, its temperature swings, becomes a reference point for understanding thousands of similar worlds orbiting other stars, worlds too distant and too faint for any current telescope to examine directly. In that sense, Neptune has become something more than just the eighth planet. It has become a laboratory, a nearby example of a planetary type that may dominate the galaxy, one we are only now learning how to read. Consider what that actually means. Every time astronomers detect a new exoplanet roughly Neptune's size, and there are now thousands of candidates identified across the galaxy, they have almost nothing to compare it to except the one ice giant sitting in our own backyard. Before Webb's observations, that comparison point was frozen in 1989 data. A single brief flyby's worth of information stretched to explain worlds trillions of miles away. Now, for the first time, scientists have a living, changing reference. They can watch Neptune's atmosphere cool in real time, track its magnetic field's strange behavior, and begin asking whether the ice giants scattered across other star systems might be just as turbulent, just as unpredictable as the one next door. A planet once treated as a quiet, frozen afterthought at the edge of our solar system has suddenly become one of the most important case studies in modern planetary science. And yet, for all of that, Neptune keeps more questions open than it answers. Why has its upper atmosphere cooled so drastically in just 3 decades? Is this part of some longer cycle tied to the planet's extreme 164-year orbit around the Sun? A cycle so long that human civilization has never witnessed it complete even once since Neptune's discovery in 1846? Or is something else driving the change, something in the planet's interior or in the way sunlight, however faint at that distance, interacts with its atmosphere over time? Nobody currently knows. The tilted offset magnetic field remains equally mysterious in its origins, a structural oddity that some scientists believe may be a clue to violent, unresolved events deep in Neptune's formation history, perhaps connected to whatever process allowed it to capture Triton in the first place. What is certain is this. For 35 years, Neptune sat at the edge of exploration, a planet we visited once, briefly, and then left to the imagination. Webb did not just take a prettier picture of a distant world. It reopened a case file that had been closed since 1989, and what it found inside was not confirmation of what scientists expected, but evidence of a planet actively changing, cooling, glowing in places nobody predicted, guarding secrets in its rings and its captured moon that no spacecraft has yet returned to investigate up close. There is, at the moment, no mission funded or scheduled to send a spacecraft back to Neptune for a longer, closer look. Everything researchers now know comes from a telescope parked nearly 1 million miles from Earth, patiently gathering photons across billions of miles of empty space, filling in a picture that Voyager 2 could only sketch and outline more than 3 decades ago. Proposals for a dedicated Neptune orbiter have circulated among planetary scientists for years, but none have yet secured the funding or the launch window such a mission would require, which means that for the foreseeable future, Webb remains humanity's only real window into what is actually happening on that distant, darkening world. Somewhere out there, nearly 3 billion miles past Earth, a planet discovered through mathematics before it was ever truly seen is still rewriting what we thought we understood about it, one infrared image at a time, and for now, the questions it is raising are multiplying faster than the answers Webb has been able to provide.